So can you explain what is a lever? Just go to the Greek time and people lifting heavy stones from their bare bodies. Can you explain how lever would be helpful in that time?
So they can attach a lever to like a mechanism that would lift up the rocks or the materials they needed.
Yeah. And how would it help it out?
So like lever को हम turn करते like उसको flip कर सकते हैं ना. It's kind of like a switch, I guess.
So
So
benefit क्या है? I know कि I can lift up basically stones वगैरह, but I still need to apply force, right? Is there any benefit of using a lever instead of just picking it up with my bare hands?
Yes, sir, it makes it easier to pick up the heavy objects.
Okay. So now let's see what benefit do we have of using a lever, right? So imagine कि you have this particular stone, right? This is the ground over here, and you want to pick up this stone, right? Let's say this is Masha standing over here. She wants to pick up this huge stone, right? And let's say the weight of this stone is let's say 5,000 rupees, right? Imagine she uses a pivot over here, right? And she fixes a lever, right? She fixes a lever over here, and she's going to apply a force on this lever, right? In this direction. Okay. And let's say she only needs a force of 100 Newton, right? So depending upon the distance, right, from here, that is D2, and let's say distance from here till here, that is D1. So imagine if my distance is greater, so my moments are balanced out, right? So because moment formula is force into distance, right? So if I increase my distance, ठीक है जी? If I increase my distance, my moment will also increase, right? So now, depending upon this, I can have less amount of force to apply to pick up a huge stone, right? So that are called levers. So these are called levers, right? So a lever may be a device which can turn about a pivot, which we have seen right down in this example, right? So in a working lever, a force called effort is used to overcome a resisting force called the load, right? So this is the load over here of the stone, and this is the effort, right? So you're applying this effort to basically pick up or roll over the stone, right? So the pivotal point is called fulcrum. Okay, so the pivot which we have placed over here is called fulcrum over here, right? So this is called fulcrum or pivot. ठीक है जी? It's just used to basically provide a point where you can basically apply moment formula, right? You apply principle of moments. So if you use a crowbar to move heavy objects, ठीक है, our hands apply the effort at one end of the bar, and the load of the force basically exerts a force on the other end, right? So which we have seen over here. You can also see this. This is a good, you can say, diagram to just visualize. You can see this is the distance from your fulcrum to your effort, right? Let's say you are applying a force here. Let's say you have a rope and you are stretching the rope from here, right? And this is, let's say, Masha standing over here, right? So she's applying the force from here, and and this is the distance, let's say distance OB, right? And this is the distance OA, right? And here is the load weight over here, that is, let's say W, which is applying a certain load component force over here. This is the fulcrum which we have seen also in the last diagram. So imagine this, just see this, right? Distance OB is way huge than distance OA, right? So since I told you guys the moment formula depends upon what? Force times distance, right? So let's say you have, let's imagine this is 5,000 newtons, and this is, let's say, 10 centimeter, right? So 10 centimeter is 0.1 meters, and 200 centimeter is 2 meters, right? So let's find out the force required, right? Let's find the moment over here, right? Let's find this moment over here. What is moment of load? Distance OA is 0.1 meter, and distance OB is 2 meters, right? So let's find the moment from the load, right? So moment of load is going to be 5,000 times 0.1. So what is the moment coming out to be? It's 500 Newton meter, right? Similarly, let's figure out what effort do we need to basically counteract this, right? So I want to lift, I want to at least provide a moment around this particular point that is equal and greater than this, right? So let me insert a blank slide. So you know, okay, what is moment OB going to be? That is going to be 500 Newton meter, right? We know the distance from the fulcrum to the B, that is distance OB, that is 2 meters, right? So distance OB is 2 meters. So let's find the effort, right? Let's find the force of the effort that is put by Mashal, right? So again, you know what is the formula of moment? That is going to be a moment. I'm finding moment of, let's say, effort, right? That is going to be moment of OB. I want to pick up this much load, right? That is going to be force of effort times distance OB, right? So this is 500 and this is equals to F into F effort times 2, right? Let's find the force that you need to apply to pick up the stone, right? That is going to be 250 newtons. Okay, so that's way small, right? Imagine you want to pick up 5,000 Newton weight and only apply a force of 250 Newton to basically pick it up. Does that make sense? The benefit of levers and moments. If it makes sense, give me a thumbs up.
Sir, can you explain this once again?
Okay. So who got this? जिसको समझ आ गया, just give me a thumbs up. हमजा को clear है, वर्दा को clear है. What about Ryan and Maeve? Okay, I guess they both are chilling out. Okay. So कहाँ पे you are lost, Ruba? There were you lost?
Sir, when you found the effort.
Is this part?
Yes, yes, this one.
Okay, let me just repeat for all of you. I believe he may also need a repetition. So you know, okay, what is this configuration, right? So you have a F stone over here and it is exerting a force of W, right? Which is 5,000 newtons in this direction, right? And you would have to apply effort in this direction to basically pick it up or let's say roll it over, right? So this is the fulcrum which we have fixed around which we are applying principle of movement, right? Make sense? Okay.
Yes, yes.
So now आपको distance OA दिया हुआ है, that is 0.1 meters, right? And you have distance OB from the pivot till the point where the force is applied, and it is perpendicular, right? It is perpendicular. So distance OB is 2 meters. Okay. So I know this 5,000 Newton W. I know the distance OA. So I found out okay, what is the moment from the load, right? That is in anti-clockwise direction.
Yes.
I found this out. So I need to at least apply this much moment around this basically in clockwise direction to basically at least reach a point that I can move the load, right? Make sense?
Yes.
So I want
Yes.
to, I know okay, my effort should be at least 500 Newton. That is equal to the load, right? Because I need to at least reach 500 Newton meter to start moving it basically or roll it over, right?
Yes.
This is the formula which basically comes out. So moment of effort which I need to apply should be at least be equal to moment that is basically provided by the load, right? That is 500. So then again, you know formula of moment. So moment is simply force into distance, right? So यहाँ पे force is the effort जो हम apply कर रहे हैं, which is applied by Mashal, which is standing over here, right? So distance, you know the distance from the pivot from the effort, okay? That is basically this DOB, right? That is 2. So you just put in the values. So this is the movement which you require. This is distance in meters and this is unknown, right? So you can just simply make F effort subject and the answer comes out to be 250 Newton, right?
Yes, yes.
Okay. So this is the force which you at least need to start rolling the stone or start picking the stone, right? Let's compare 5,000 Newton that was applied by the, let's say, the weight of the stone, and you just need 250 Newton to basically move it over. That is the benefit of levers. Now, does that make sense? Give me a thumbs up if it makes sense. Okay, good. Okay, good, perfect. Okay. So this is how the Greeks picked up huge stones in their time and they made the pyramids which are found in Egypt right now. Okay. This, if you have seen the pyramids of Egypt, basically physically or through videos, they are huge stones, right? They are huge stones. So People used to first of all pick them up with bare hands, and they used to use elephants वगैरह to drag them. But they invented this particular phenomena which made the lifting and the movement easier, right? So they just used to lift the stone and place them on the carts. So also at that time, wheels were also invented, right? We were able to invent wheels, right? Using stones. So we then used to use elephants to basically drag them around, right? So let's say this is your carriage, and this is the huge elephant over here. Imagine this is an elephant, right? This is an elephant, and they used to just use the lever to basically place it over here, right? And then they used to move around this particular pyramid, let's say stone, to the desired position. Okay. So again, a lot of things were found in Greek times. Okay, wheels, carts, okay, and levers. Okay, and they also found the distance from the sun to the earth. Okay, using some methods which you will see in your future lessons of physics. Okay. So again, levers is also this. You might have seen this in let's say in areas where there's construction, or let's say if someone is moving around some stones or some weight. Let's say if you usually they are found in constructions. So you can see, okay, the load is over here, right? This is the load over here. Let's say this is sand which needs to go to a construction site. This is the fulcrum, right? Because everything is balanced over here when the driver or let's say a person is moving this carriage, right? They hold it up and they basically balance everything on this fulcrum, right? So you can see here the load is at this particular site. This is let's say center of this particular mass of this particular load, and this you want to apply basically effort upwards, right? Because obviously it is moving down due to the weight. You want to apply a anti-clockwise basically effort to basically lift it up from the ground and then start moving it out, right? So again, we invented wheels and movement of material from one point to others became easy, right? So it is an application of levers. Imagine working out, right? So you might be working out your biceps, or just simply you are just basically pumping up your biceps. So what is happening over here? How does your biceps basically get pumped? That is due to again lever mechanism. When you lift weights, your weight basically has a component in vertical downwards. That is the weight of the weights, okay, or the load, and your muscles are basically providing you effort in this particular direction, which basically cause a pump in your muscles, and you basically get revved if you keep on doing this exercise or workouts and daily routines. Okay. So again, one of the application of levers. Okay. This is pretty simple, right? And you can see the load is this, the center of this particular scissor is this, and it has a component in this direction. Again, everything is balanced on this, we can say fulcrum. And then you apply forces with the fingers in this direction to provide a counter force to again move it in the opposite direction. Yes.
Sir, fulcrum is basically the pivot, right?
Yeah, pivot around which it is centered,
Okay.
right? Which is holding everything together. Okay. Then you have conditions for equilibrium, right? So equilibrium may we have seen, okay, you should have sum of forces should be zero, right? Let's say if you have this, which was your homework, right? Let's say this was your weight of the rod or the lever, and this was let's say P, this was Q, right? So let's say this is balanced right now. So your P plus Q is equals to 600. That is why it is balanced. You can see okay, this force is downwards, the 600 Newton is downward, and P and Q are basically trying to balance it out, right? Because this pivot is exerting a force upwards, that is P, and this pivot, that is pivot 2, is exerting a force that is upward Q. So P plus Q is providing opposing forces to balance out 600 Newton, right? So this equation can be used in your homework, right? So you can use now this equation, okay, for this question. Okay, so then the law of movement must apply. That is, imagine if you have a pivot over here, and if you have let's say a pivot, let's say something mass 1 over here, and you have a set of moments over here. This is let's say producing anti-clockwise moment, okay, and this is producing clockwise moment, right? So your moment anti-clockwise, sum of anti-clockwise moment should be equal to sum of clockwise moment. Okay, that means they should be equal. So if you subtract moments, anti-clockwise moment from clockwise moments, you should get 0. Okay, so there should be no resultant force and there should be no resultant moment also. Okay, if just imagine if the object is having no rotational motion, okay, either in this direction or in this direction, and the object is not moving upwards or downwards, that means it has zero resultant force. Okay, this scenario means it has zero resultant force. It is not accelerating, and this means if it is not it is either not rotating in clockwise direction or anti-clockwise direction, it means it has zero resultant moment. So if it is clear till now, raise your hands or give me a thumbs up, not raise your hands.